Hi everyone, today we're going to talk about the problems that are on the review in preparation for the Unit 5 Test 1 over rational operations. So the review starts out with the rational parent function. Now yes, the rational parent function is not a rational operation, but it's where all of the operations kind of stem from. And so we're going to talk about the rational parent function just a little bit before we move on to the operations. You do have a set of notes on the rational parent function, but you might have to dig through for a while because it's what we did at the beginning of our rational unit. So number 1 says graph and identify the key attributes of the rational parent function. So in order to be able to do that, you need the equation. The root word of rational is ratio, and a ratio is a fraction, and the simplest equation with x and y and a fraction would be y equals 1 over x. You might be thinking, why do we not put x on top and make it y equals x over 1? But that would just be y equals x, and that's the linear parent function. That's already taken. So the rational parent function is y equals 1 over x. The steps to find all of these pieces are actually coming from the graph, and in order to graph, we need a table. So I'm going to make an x and y table and create some x values, so maybe like -8, -5, -2, -1, 0, and then all of the positive counterparts to those x values that I had at the top. Now, I just created these numbers. You don't have to know certain x values, but I was trying to pick x values that were around 0 and that would fit on our graph. So no smaller than -10, no bigger than 10. So that's how I picked these values, and I just kind of picked random ones. So when you insert your x values into the equation, they end up becoming the denominator, and the numerator is 1. So if you take -8 and substitute it for x, you have 1 over -8 as your y value, and that's really just -1/8. So all I did was move the negative out instead of keeping it in the denominator. Same idea when x is equal to -5. -5 gets inserted here. You have 1 over -5, which is really just -1/5. And so I'm going to go through and put my x's in the denominators, creating my y values. -1, when I insert it, I have 1 over -1, and that's just -1. But an issue occurs when we get to an x value of 0, because 1 over 0 is undefined. We can't plot a point where x is 0 and y is some value because it doesn't exist. You can't divide by 0, so this is undefined. There is no point where x equals 0, which is going to become important here with the intercepts. So I'm going to continue inserting my x values into the denominator. 1 divided by 1 is 1, 1 divided by 2 is 1/2, 1 divided by 5 is 1/5, 1 divided by 8 is 1/8. So now I have a nice set of a whole bunch of ordered pairs that I can go plot on my graph, because part of my problem was to graph the rational parent function. So when I graph -8, -1/8, I'm going to go all the way over to -8, and I'm only going to go down a little bit. The limitations of ink on paper, pen on paper, is that a lot of times your points kind of bleed into axes, and in reality, the point doesn't have any certain size, and so in reality, it's not quite on that 0. It's not quite on the axis, but it's very, very close. So I'm going to continue plotting. It's not really going to look like my points are moving up or down at all, because they're going to continue to be just underneath my axis. But -5, -1/5, -2 and -1/2, it's about halfway. 1, -1 right there. There is no point where x is equal to 0, so I don't put anything on the axis. And then I skip down to 1, 1. 2, 1/2, 5, 1/5, and 8, 1/8. So this almost looks like whenever you are, hooked up to something that's monitoring your heart rate, and it kind of goes and then it goes down and then it boops and then it comes back up, right? And then it comes back down again. So that's kind of the shape of this. This is called a hyperbola, not a parabola, but a hyperbola. And what it looks like is something that comes from the left side. It's very, very close to the axis. It's going to curve down, and then it's going to approach the y-axis over there. Now it's never going to touch, but it is going to get very, very close, and hopefully that language triggers a term in your head, because what happens is that here on this line that is the x-axis, or sorry, the y-axis, and x equals 0, there's an asymptote. It's going to approach, but it's never actually going to touch. Same thing here. It's going to approach, but it's never actually going to touch. That's an asymptote. And because there's no point where x equals 0, but my graph kind of curves up here, that means that my graph comes back down. It's going to curve some more, and then it's going to try to flatten out. It's going to approach the x-axis, but never actually touch. So we have some asymptotes. Those asymptotes appear on the axes. So I have one asymptote here, the vertical one, and it happens to have an equation of x equals 0. So my vertical asymptote has an equation of x equals 0. And then the horizontal asymptote is here. Again, the graph approaches the axis, but it never actually touches. And that equation of that asymptote is y equals 0. So there's no points where x is 0 or y is 0, and that becomes important because when we're writing our domain, from the left side to the right side, I can't put boundaries because there are arrows. So my domain is all real numbers. However, there is a vertical asymptote where x equals 0. There's no point where x is 0. And so our domain is all real numbers except x cannot be 0 because there is an asymptote there. So this should match up. Now with our range, the idea is similar. Our range is from bottom to top. So I go from arrow to arrow. That's all real numbers. However, there's an asymptote right here going right through the middle of the problem. And so there are no y values that equal to 0 because there's an asymptote here. No point lies on that line. So y cannot be equal to 0 because there's a horizontal asymptote. And that affects our intercepts because we said that x cannot be 0 and y cannot be 0. So there's no ordered pairs that I can write that would fall on the axes. So there are none. No places where the graph crosses the x or y axis because there's asymptotes on those axes. So that's just a brief review of the rational parent function and its key attributes. Let's move on to operations. So the first operation we talked about in this unit was long division. Number 2 says divide using long division, show all work. So I'm going to take what I have here and I'm going to write it inside what we call kind of like the little division house. So 8x cubed minus 10x squared plus 17x plus 5, making sure I don't skip any terms, cubed, squared, x, and constant, that's good. And the 4x plus 1 is outside. And when you do long division, the steps are divide, multiply, subtract, and bring down. And when you divide, you're only dividing the first terms. So I have 8x cubed divided by 4x. 8 divided by 4 is 2. 2 cubed divided, or sorry, x cubed divided by x is x squared. So 2x squared is my first term. We divided. Now we multiply. We multiply with distribution. So 2x squared times 4x gives me this 8x cubed again. But 2x squared times 1 is plus 2x squared. So we multiplied with distribution. We subtract, so we draw the line. We change both signs. That will cancel out the first term. We'll have no x cubes. But negative 10x squared minus 2 more x squared is negative 12x squared. So we subtracted, and we bring down the next term with its connecting sign. And we start all over again. We divide the first terms. So negative 12x squared divided by 4x. Negative 12 divided by 4 is negative 3. And x squared divided by x is just x. When we multiply, negative 3x times 4x is negative 12x squared. We get the first term back. Negative 3x times 1 is minus 3x. When we subtract, we draw the line. We change both signs. Negative 12x squared plus 12x squared is 0x squared. 17x plus 3x is 20x. Bring down our next term with its connecting sign. And we start the cycle over. We divide. 20x divided by 4x is 5. So 5 comes up here. We distribute. 5 times 4x is 20x. 5 times 1 is 5. When you subtract, you draw the line. You change both signs. 20x minus 20x is 0x, and 5 minus 5 is 0. That's a remainder of 0. So my answer is 2x squared minus 3x plus 5. And our steps were to divide, multiply, subtract, and bring down. Okay, so let's try our next problem, again with long division. So I'm going to write my first polynomial inside. So I have x cubed, and then minus 6x squared. I'm missing an x term, so I'm going to insert a plus 0x, and then a plus 1, my constant. And x plus 2 is what I'm dividing by. My steps are divide, multiply, subtract, and bring down. So when I divide just the first terms, x cubed divided by x is x squared. So that goes above my x squared. I multiply with distribution. X squared times x is x cubed. X squared times 2 is 2x squared. I subtract, so I draw the line, I change both signs. X cubed minus x cubed is no x cubes. And negative 6x squared minus 2 more x squared is minus 8x squared. Bring down your next term, with its connecting sign. And I start division over again. First term, negative 8x squared divided by x leaves me with negative 8x. When I distribute, negative 8x times x is negative 8x squared, and negative 8x times 2 is minus 16x. Draw the line, change both signs. I have no x squareds, and then I have 0x plus 16x, which is 16x's. Bring down my plus 1. Last cycle, 16x divided by x is 16, so that's my constant. 16 times x is 16x. 16 times 2 is 32. I draw the line, I change both signs. 16x minus 16x is no x's. 1 minus 32 is negative 31. That's my remainder. So I write it as minus 31 over x plus 2. So that's my final answer. X squared minus 8x plus 16 minus 31 over x plus 2. If a question asked if this polynomial was divisible by x plus 2, the answer would be no, because it has a remainder. If the question asked, is x plus 2 a factor of this polynomial, again, the answer would be no, because you have a remainder. Now, synthetic division seems to be most people's favorites. When you use synthetic division, you want to write your coefficients of the polynomial, but I notice that I'm missing a lot. So I have x to the 5th, I have no x to the 4ths, no x to the 3rds, no x squareds, no x's, and then a minus 1. So keep that in mind, that your coefficients must include the zeros if you have missing terms. So I have 1, 0, 0, 0, 1, negative 1. And my r value is the opposite of what I have here, what I'm dividing by. So instead of negative 1, it's a positive 1. So my steps are to write coefficients R value equals the opposite of what you're dividing by, that constant you're dividing by. Bring down your first term. Multiply. 1 times 1 is 1. And then add down. 0 plus 1 is 1. And then you continue. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. Negative 1 times minus, oh my goodness, negative 1 plus 2. When you get into a rhythm and it gets messed up, you say things that are wrong. Sorry about that. So now these are all coefficients of my answer, but I start with the power that is 1 less than what was in the problem. So if this is an x to the 5th power, then this is the coefficient to the 4th power. And an x to the 3rd power, and an x squared, and an x, and a constant, and a remainder. So plus 1 over what we were dividing by, which is x minus 1. Alternately, you could write these without the 1s, and that would be totally fine. It would probably look much better, actually. So the idea is the same in number 5. We're going to write the coefficients. So I have a 2, negative 5, 4, negative 4. My R value is the opposite of negative 2. I bring down my first term, and I go into my cycle of multiplying and adding. 2 times 2 is 4. Negative 5 plus 4 is negative 1. Negative 1 times 2 is negative 2. 4 plus negative 2 is 2. 2 times 2 is 4. Negative 4 plus 4 is 0. That's my remainder. This is an x cubed, so that means this is a coefficient of x squared. 2x squared minus 1x plus 2, no remainder. That's synthetic division. Number 6, simplify, multiply, and divide rational expressions. So we want to make sure that we cancel out only common factors that we have on top and bottom. And so when we do that, we've got to make sure that anything left over stays in its spot. So if it's left over on the top, it stays on the top. If it's left over on the bottom, it stays on the bottom. So I'm going to go ahead and I'm going to multiply these top two things that we have here. So we've got a 2 times a negative 2. And that's negative 4. We have an x times an x squared, that's x cubed. Then we have the y cubed and the denominator. Okay, so things that cancel out. We're just simplifying here. The negatives cancel out. The 4 and the 3, those can't be simplified, so we'll have a 4 on top and a 3 on the bottom. The x cubed and the x to the 4th power, well, if you subtract 3 minus 4, you get negative 1, so that means that there's an x left over on the bottom. Think of it this way. If you have x cubed, that's x times x times x, and if you have x to the 4th power, that's x times itself 4 times. Common factors that can't get canceled out are these x's, and then there's just an x left over on the bottom. So you leave what's left over wherever there were originally more. Same thing here. If you have y cubed on the top and y to the 4th power on the bottom, they all cancel out except for a single y that's left over on the bottom. In number 7, we're multiplying. But we have 2 separate ratios, and so I want to make sure that I factor all the pieces so that I can get a good idea of common factors that are on top and bottom that I can cancel. So here, using the trinomial, I want to factor with magic numbers. 2 numbers that multiply to give me 14 but add to give me negative 9 would be negative 7 and negative 2. So a minus 7 and a minus 2 are my factors for that denominator. This does not exist anymore because it was changed to be this. Here, it's a binomial, so I want to see if I can take out a GCF, and I can. I can take out a 10a. 10a squared divided by 10a would just leave an a. And minus 20a divided by 10a would just leave minus 2. And this is no longer there because it was turned into 10 times a minus 2. So what we have is an a minus and an a minus 2 on the top. And on the bottom we have an a minus 7, an a minus 2, and an a plus 5. So I want to factor and then cancel common factors. So I notice that the a minus 7s are the same on top and bottom. Those can be canceled. A minus 2s are the same on top and bottom. Those can be canceled. But that's all that can be canceled. So what I'm left with is 10a on top and a plus 5 on the bottom. The idea for number 8 is the same except for it's being divided. So what we're going to do is replace that division sign with the multiplication sign, and we're going to multiply by the reciprocal. So 6x squared cannot be factored anymore. 6x cubed minus 6x squared can be factored. I can take out a 6x squared. I'm left with an x minus 1. And I'm going to multiply that by the reciprocal. So x plus 5 over 1. Now I notice that I don't have any repeating x plus 5s or x minus 1s, but the 6x squared appears on top and bottom. So that can be canceled. And what I'm left with is x plus 5 on the top and x minus 1 on the bottom. Number 9, add and subtract rational expressions. You want to make sure you get a common denominator here. So when I factor, I'll take out a GCF of 2. And then the magic numbers that multiply to be 8 and add to be negative 6 are negative 4 and negative 2. So I no longer have this. But I do want this to have the denominator of 2 and x minus 4 and x minus 2. So I need to multiply this by whatever I need to get that denominator. And I need all of it because there isn't a denominator here. So I'm going to multiply by 2 and x minus 4 and x minus 2. And 2 and x minus 4 and x minus 2. So my denominator is 2 and x minus 4 and x minus 2. But my numerator is now a little different. It's x minus 8 plus 2 times 2, which is 4, times x minus 4 times x minus 2. What I'd like for you to do is pause your video. I'd like for you to FOIL this, distribute in the 4, and combine your like terms that you see in the numerator. Okay, sorry for the glitch. So when you FOIL these two, you end up with x squared minus 6x plus 8. So it's kind of like working backwards here. When you distribute the 4 to all three terms, you get 4x squared minus 24x plus 32. You want to combine that with the x and the minus 8. So you get 4x squared minus 23x plus 24. We kept this denominator the whole time, and this is your final answer. You might want to check to make sure that this can't be factored, but 4 times is 96, and there's nothing that multiplies to give you 96 and adds to give you negative 23, so it stays as it is. Number 10, we're subtracting. I want to my denominators, so I can factor out a 4. The LCD needs a 4 because they both have a 4. It needs a single x because this one has an x. And it needs an x minus 8 because this one has an x minus 8. So that's my LCD. This denominator has a 4 and an x, but not an x minus 8. This denominator has a 4 and an x minus 8, but it doesn't have an x. So now I have 4 times x and 4 times negative 8 minus 5 times x. And it's all over that common denominator, that LCD, which is 4 times x minus 8. Now the only thing that I can do here is combine my x terms, and 4x's minus 5x's leaves me with negative 1x's. But nothing else has changed. So that is my final answer. And lastly, we move on to solving rational equations, which is the most recent topic in our notes. So hopefully it is the most fresh in your mind, but it's also what we've practiced the least. So number 11 asks us to solve the equation, check for extraneous solutions. I want to do what I've done in my other problems, which is factor the denominators. And find an LCD. And in this case, in order to cancel out any fractions that we might have, we want to multiply all terms by the LCD. And that way we can cancel out our fractions and solve our equation. So when I factor my denominators, it's a binomial. I can take out a GCF of 4. That leaves me with x plus 7. So this is now gone and it's replaced with 4 times x plus 7. Same thing here. Those are my only two denominators. This denominator is 1, so it really doesn't have anything to contribute to the LCD. So my least common denominator is 4 times x plus 7. I want to multiply everything by 4 and x plus 7. So this term gets multiplied by 4 and x plus 7. This term gets multiplied by 4 and x plus 7. This term gets multiplied by 4 and x plus 7. I notice in this fraction that the 4's are common factors that can be canceled out. The x plus 7's on top and bottom, common factors to be canceled out. All that remains is the 7 minus. Nothing gets canceled out here, but 2 times 4 is 8. And I'll need to multiply that by x plus 7 with distribution. And then in that last fraction, the 4's are common factors, they can be canceled out. The x plus 7's are common factors, they can be canceled out. And the 3 remains. So in order to solve, we've got to distribute this negative 8. We want to combine our like terms. Now a lot of students here want to subtract 7 and subtract 7. You only do inverse operations when you're moving something to the other side of the equation. But here I'm just combining the 7 and the negative 56 on the right side. So I'm just going to combine them. 7 minus 56 is negative 49. I'm going to move the constant. I'm going to divide by the coefficient. X equals 52 over negative 8. That's not a nice pretty integer. However, I can simplify numerator and denominator by 2. So 52 divided by 2 is 26. Negative 8 divided by 2 is negative 4. I can simplify by 2 again. 26 divided by 2 is 13.
Negative 4 divided by 2 is negative 2. So I'm hoping that x equals negative 13 over 2. However, I do need to make sure that my solution that I found does not create denominators of 0. So I need to check. And the way I do that is I make sure that each part of my LCD does not equal 0. Well, if I set 4 not equal to 0, well, that doesn't really tell me anything. However, if I set x plus 7 not equal to 0, then x can't be negative 7. It can't be the opposite of this constant right here, which is okay. That doesn't interfere with the solution that I got, so my solution is negative 13 halves. That does not make my denominator 0. And finally, number 12, with the same steps as number 11, we want to factor the denominators. P plus 1 can't be factored anymore, but both p squared plus p here and here, we can factor out a p and factor out a p. So my least common denominator has all the pieces of the denominators. So a p exists in 2 of those denominators, and p plus 1 is in all of them. And there's nothing else in any denominator, so this is my LCD. So I'm going to multiply everything by p and p plus 1. And I'm going to start canceling. P's on top and bottom will cancel. P plus 1's on top and bottom will cancel. A 4 remains, equals. P plus 1 cancels on top and bottom, so I'm left with 1p, minus. P's on top and bottom cancel, and p plus 1's on top and bottom cancel, leaving minus 1. And now we have a simple equation to solve. I move my constant, I get a p-value of 5. So let's make sure to check that 5 will not give us a denominator of 0. So when we check, we're just going to check that each piece of the LCD does not equal 0. So p itself cannot be 0, because if it is, then this will be 0 and this will be 0, making undefined terms. Now let's check p plus 1. P plus 1 can't be 0. If that's the case, then all of these denominators will be 0, and that's not okay. So p can't be equal to negative 1, and that's okay. It doesn't interfere with the solution that we got, so our solution for this rational equation is 5. Now before we finish the notes, or the review, I do want to go back to number 4, because as I was doing number 11 and 12, I noticed that on number 4 I made a mistake. So perhaps while I was going through it, you noticed that something was wrong. And if you noticed that, awesome. Number 4, x to the power of 5 minus 1. When you rewrite it, you do have to put in all of these 0 terms. However, there wasn't an x term, and I said there was, because I gave this a coefficient of 1, and it shouldn't have been. It should have been 0. So this should have been 0. And what that means is that whenever I add 0 and 1, I don't get 2, I get 1. 1 times 1 is 1, and negative 1 plus 1 is 0. So I should have had 1x to the power of 4 plus 1x cubed plus 1x squared plus 1x plus 1. And I shouldn't have had any remainder. So if you were wondering why I got that, that's because there was a mistake. So don't make that mistake. Put in 0 terms for the terms that are missing. Don't put in a 1 for the coefficient.